Today in the first session, so we'll be going over the basics of what actually artificial intelligence means and what is the meaning of machine learning and deep learning. So in this session, the first thing that we will go is we'll see what is meaning of the AI ML, what do we mean by artificial intelligence, and what is machine learning, and then what is deep learning basically. So we'll go on these learning about these terms, then we'll move on to the history, how it all started. So I'd like to start everything because they're in this artificial intelligence. Can anybody just give his comment on what does this intelligence word mean? What do you understand by the word intelligence? What is meaning of this word intelligence? Any comments, like if you have any thoughts on what do you understand by intelligence? Then probably you might know what is artificial. Artificial means it's induced effect, it is not natural. So Umar, you wanted to say something?
It is the ability to learn or understand to deal with new things.
Right. The ability, so the definition he gave is it's the ability to deal with the new things by, for example, if you see something and you have ability to adapt to those conditions. So that's what we mean by intelligence. And sometimes we perform the tasks that we haven't done, and we see some person doing a task, and we learn from it. So that's what, in a broad sense, not in a formal sense though, it is intelligence. And somebody even commented something, so I'd also see his message. So Muhammad Faiz said that capacity to do work on itself. It's also a good definition, fits this, that if somebody without being explicitly guided, okay, do this, he's able to make his own decision, or a machine, for example, it's able to make his own decisions. That's what we actually mean by intelligence. Actually, there are formal definitions of intelligence as well that we won't be going into deep, because then it becomes a philosophical question. Okay, what do you mean by this and that? So by artificial intelligence means, like, initially if you see, humans had to do everything. So if you see here what we have defined as any technique that enables computers to mimic human intelligence. So intelligence means that they should do the things on their own, as somebody said, that capacity to work on itself. So here we have mentioned it. Any technique that enables computer to mimic human intelligence using logic and other rules, this includes basically the artificial intelligence. So anything that a human is capable of doing, if we make a machine like that so that it's able to do the same task without being told what to do, like exactly the steps. For example, if you talk about algorithms, like usually we have algorithms. So in algorithms, what we do is we'll write step-by-step guidance. If we have to make a cup of tea, for example, we'll write step 1, do this, step 2 and step 3 like this, and we'll give a stepwise procedure. That is actually not intelligence, because you are guiding some particular thing, probably a machine or a human being. That's not being intelligent. By intelligence, I mean that the machine or a human should be able to do it on its own. So that's what I mean. Here, artificial intelligence, it means all those techniques that enable particularly computers to do something on their own without being explicitly told what to do. And then comes the machine learning. We'll see why these things came up, and it actually has a historical background. Why these machine learning came up, if artificial intelligence was much enough, and why this machine learning was named like this, and then what is deep learning, and we'll see that. So first, I would like to again emphasize on what is the difference between this traditional programming and machine learning. If you see this on the screen, let's say we have a problem to solve. If you are working in a banking sector, a lot of transactions, there are people who do fraud transactions. For example, they'll do some tinkering with the system, and with that system they'll try to do a transaction which is actually illegal. So we have to detect those frauds in the machine. For example, if we have this transaction data, and out of these transactions we want to know that what are the transactions that have committed fraud. So in that, one approach is that we'll write a bunch of rules, basically the program, and that will find something in. For example, let me take a small example, simpler example. Even if I am given two numbers, like I am given number 1 and number 2. So my task is to sum these numbers. This is my task at hand. So in the traditional programming, what we basically do is we'll just write a set of sequences, basically the steps, which we call an algorithm, which will take these two things as input, and then that program which I will write for the machine as an input. So this will go into the machine, and it will give output as the sum of these numbers, number 1 and number 2. Am I clear?
Yes, sir.
So what I mean by is, for example, if you have a task in your hand and you want to write a program, so for that you have to the computer. If you see here, we have a computer. To this, we give this data, transaction data, for example. This is actually data on which to operate, and then we give rules, basically the program. Program is not a set of rules. Algorithm is just stepwise, some steps which the computer understands. Then this computer will manipulate, this machine will manipulate it and provide whether a transaction was fraud or not. In the similar scenario, if we have some other problem at hand and we want to create a program for that, if you see, most of the things that you do is basically done by this traditional programming. If you want to make a website, so for that you have data, you have the text as your data, and then you write a program how to process the data. This data and this program, this goes to your machine, and then this machine produces some output, for example a beautiful looking website or something like that. So that's the traditional approach to programming. And if I can tell you, okay, can you write a program, for example, for a thing which if I give it image, it should detect, for example, it should differentiate between cats and dogs. Let's say I have some data in which we have cats and dogs. Okay, so I want you people to write a program for that, which this data and that program will go and will be fed into the machine, and then machine should differentiate whether the image was cat or dog. Okay, so if you do anything like that, you have data and you want to manipulate their data based on the programs humans have written, based on the explicit instructions that you give to the computer. That is the way how traditional programming is done. If you are even familiar with some basics of programming, there you will write a program, then some input you will give to the data, and then computer will sort of do some manipulation of the data and produce a result. So how does this machine learning or AI does the work? It actually is the reverse process of that. So what we do is, we'll first give it the transaction, we'll give it the data, and we'll give it the goal. Okay, what is the thing that we want to do with the data, and then it will come up with some rules. So by that I mean, if I again take that data example of these cats and dogs, I'll just give a bunch of example of cats and dogs. I'll feed these cats and dogs, and I'll feed also these labels. For example, in a setting where we call it a supervised learning setting, we'll give some additional features like we have this is a cat, this is a dog. We'll train it on multiple examples. Then this machine will learn the rules. Okay, maybe cats have more stats, dogs don't have. Cats are smaller in size, dogs are bigger in size. So this machine will spit out the rules basically, and then by using the rules, and this usually is called a machine learning model. So when we get model out of this, then when we have this model, then we'll just give it to the data, and it will give us the output that we want. Is the differentiation clear between what's the difference between the traditional programming and the machine learning? Like in a broader sense, in traditional program, what we do is, the basic thing is that you will give the data, you will give whatever you want to manipulate, basically the input I'll say, and then the rules, the program, the algorithm, and you will feed both of these in the machine. Then machine will act on that thing, the data, by using those rules, and it will manipulate and try to come up with the desired result that we want. But machine learning is completely reverse of this. First we'll give it data and the outputs as well, the desired outputs. So that's why afterwards we'll feed that into the machine, and then machine will come up with the rules. It will basically come up with the program that will do that. Okay, so to just write it over here, I'll just for example, this was the machine. Initially it was fed with the data and the objective that we wanted to achieve. So here it gave this machine, it gave us actually the rules, which I told that it is called the machine learning model. Then these rules, we will input some unseen data. By unseen data I mean that the data that was not used when we generated that program, and this data when fed it into these rules, and it will give us the output. So you can clearly see there are two phases. There are two phases in this. The first phase is this phase, where we give the machine the data and the objective that we want to achieve, and by machine analyzes data by using the machine learning algorithms. That algorithm we will learn in the course, and then it produces a set of rules or some program which we call a machine learning model. That's the first step. Step one. Step one is that we actually make a model. And in making of the model, there are multiple steps involved. As you see, we feed the data, we give it an objective, then there are algorithms running, and then it comes up with a model. That's the step one, broadly speaking. The step two is that by using this model, we'll again feed it the unseen data that was not given it before. Then it will come up with an output. The first step is called the training phase. the training phase, and the step 2 is called the testing phase, or the inference part, in which we infer something. Okay, am I clear till this point? So I'll just reiterate the things. The first thing, if you see that there is a difference between traditional programming and machine learning. In traditional programming, we have some input or data on which we want to manipulate this data and produce some output. For that, we'll write our own programs, our own steps, our own rules, and give it to the machine or give it to the computer that we want, and it will give us the output. In the machine learning, I broadly told that there are two things happening. The first thing is training phase. Training basically means when you have data and you have the objective as well in your mind. This basically, if you ask question to yourself, in the when a child is born, how does he learn? He basically learns by using this. So, for example, he sees many other people around him. So he then he or she, after a while, after 6 months, after 10 months, the brain continuously takes the input from the environment. He or she sees his or her mother, father, and then he's able to identify after a while that this is my father, this is my mother. Basically, that is basically the training. And in artificial intelligence, as I told you, we want to mimic the human brain, how actually human brain works. Similar thing happens here. So we are in the first training phase. We give data and the objectives as well. That this is the thing that we want, and then machine learning process that finds some pattern and then gives a machine learning model to us. And based on that machine learning model, we'll give it the unseen data. And on the unseen data, we want to predict something. Again, let me take a concrete example of that. For example, let's take example of the weather. Okay, in weather, we have data, for example, of previous, let's say, 2 years. For each day, there is a temperature, max temperature, minimum temperature. So we have that. So you cannot come up with the rules. If you want to write rules, then you have to measure everything. For example, you'll measure precipitation, humidity, and things, and make a program. If precipitation is this much, then probably there is a percentage of chances of rain, and then you'll have a number of factors in that. So these number of factors will decide whether it will rain or not. The other approach is that by using that data or even the previous data that we have, we'll come up with a pattern and we'll ask machine to find the pattern in it. And by using that pattern, for the next day we will be able to predict something. So things like that we'll be handling in the machine learning. So this artificial intelligence part is clear. We wanted to see are there some techniques, can we come up with the techniques which will mimic sort of human brain and human intelligence.